Hello and welcome to this second video on mole calculations. So this time around what we're going to be talking about is a slight enhancement on the first video. So in the first video we talked about this equation here, moles equaling our mass divided by our MR. And we talked about elements. We talked about how to do these calculations with elements. So we talked about where we get this value of MR from for the elements, and we talked about looking at the periodic table and getting their relative atomic mass. Okay, so we have elements, we go to the periodic table. So what happens though when we have something like a molecule, or we have a compound? So this is where the slight difference comes in, and I'm just going to talk through two examples that will hopefully answer this question. So let's start with a molecule. Okay, so we could be given a question where we're asked about oxygen. So oxygen exists diatomically. So I hope that if somebody was to ask you the question, what is the formula of oxygen, you would say it is O2. Okay, oxygen exists diatomically, it's O2. So let's say, for instance, I have 16 grams of oxygen. Okay, how many moles is this going to be? Okay, so if we follow through our logic, we write out our equation, so we know that the moles is going to equal the mass, which in this case is 16, divided by the MR. Now the question is, okay, what is our MR? Now what we need to look at is we need to look at this here. Okay, it's O2. Now if you were to look at oxygen on the periodic table, you'd find oxygen, okay, and you would find that it has the number 8 here, and it has the number 16 just here. Okay, so oxygen has a mass number of 16, an atomic number of 8. Okay, so how does this fit in with our MR? Well, when we're looking at MR for a molecule, we have to consider every atom that's present. Now O2, okay, comprises of 2 oxygens. So what our molecular mass is here of oxygen is it's 2 times by 16, okay, which equals 32. So the last time around I talked about the sort of relative atomic mass, and we talked about how we looked at that as a mass of an element, so 1 mole of that element would equal this. Here we've got a molecule of O2, so if I had 1 mole of oxygen molecules, it would weigh 32 grams. So this number here is the number that I need to put in my question mark. So this number is 32. Okay, so when we then look at this question, okay, we have moles equals 16 divided by 32, which means that my number of moles equals 0.5. Okay, so all I did was I added up the masses of the atoms present in this molecule. So there are 2 oxygens in an oxygen molecule. Okay, so let's apply that to a different scenario. What about a compound? So last time round I talked about what if you had methane. Okay, so methane is CH4. Okay, so let's say, for example, here I have 40 grams of CH4. Okay, how many moles is that? Okay, so again I write out my equation. So I've got moles equals 40 divided by my MR. But again, I don't know what my MR is. How do I work that out? Okay, well, what I need to think about is what is present. Okay, so I've got CH4. Okay, so I've got CH4. So what this means is it means I've got 1 carbon and I've got 4 hydrogens. Okay, so I know I've got those. So I use my periodic table to find out what the mass of these 2 things are. So if I go and look at carbon, we've talked about carbon already, has a mass of 12. 1 times 12 equals 12. Okay. Hydrogen, if I look at hydrogen, hydrogen has a mass of 1. So therefore 4 times 1 is 4. So what that gives me is that gives me a total of 16. Okay, so then when I go back to this calculation here, okay, all I'm going to do is I'm going to just write 16 under this part here, okay, because my MR of methane is 16. So then my number of moles equals 40 divided by 16, okay, and 40 divided by 16 is 2.5 moles. Okay, so my answer is 2.5. So essentially there's just an extra step, okay, and that extra step is ensuring, okay, that you calculate whatever the MR is, okay, so we just need to calculate the MR of the molecule or compound, okay. So that's the new thing that we've just talked about in this lesson here, okay, calculating the MR of the molecule or compound. So as again, I'm going to give you a question, follow it through, and see how well you do on that. So utilise the stuff from the first lesson, also the second lesson, and we'll see how well you do. Okay, so here's a question for you to have a go at. What is the mass of 5 moles of sodium chloride? So have a little think about what you've got to do in this question. Okay, put out the steps that you're doing, work through it, pause the video right now, and then we'll talk through the answer to make sure you're doing everything correctly. Okay, so best of luck, give it a go, and I'll catch you in a couple of minutes. Okay, so hopefully you've had a go at that. Let's see how you've done. So what is the mass of 5 moles of sodium chloride? So first things first, as I said, good practice is to highlight some of the key things in the question. So first thing, we've got mass, okay, we've got 5 moles, and we've got sodium chloride. Okay, I'm just going to highlight the formula because that's the important part for me. So first things first, I'm going to write out my equation. So my equation is moles equals mass divided by my MR. Okay. Now, first things first, what we should notice from the question is actually we're after the mass. So step number 1 in answering this question is going to be rearranging our equation. So we rearrange our equation so that the mass equals moles multiplied by RMR. Okay. So step number 2, okay, in this, we know how many moles we've got, okay, because that's written in the question. So we've got 5 moles. But what we don't know is we don't know what the MR is. So we've got to calculate the MR. Now we're working with sodium chloride. So sodium chloride is NaCl. Okay? So we've got sodium chloride, NaCl. So what's in NaCl? Well, we've got 1 Na and we've got 1 Cl. So when we're working out the mass of 1 mole of our compound, we just multiply, okay, the mass of each element by how many atoms there are of that element. So sodium has a mass of 23, and chlorine has a mass of 35.5. So that means that our sort of MR of sodium chloride is 58.5. Okay, so we can now put this, okay, into our calculation. So we've got 58.5. So now all we need to do in step 3 is just multiply those two numbers together to get our mass. So our mass equals, okay, 292.5 grams. Don't forget, the units is really, really important. Okay, so if somebody was going through and marking this, what kind of things are they looking for? Well, they'd be looking for you getting the right equation. So even if you don't know what the information is and you write down the correct equation, you'll probably be able to pick up 1 mark. Okay, there will then be 1 mark, okay, for getting the answer correct, and then the last mark will most likely be for getting the units correct as well. Okay, so there could be up to 3 marks for a question like this. So, hopefully from this video, what you've been able to do is you've been able to look through a mole calculation, Okay, not just for an element, but now also for a molecule or a compound. So, what we're going to look at in the next video is we're going to look at how we can use mole calculations to work out the amount of particles and how we do that. And then we'll look at some more advanced mole calculations after that and talk about something called reacting masses. So, as always, thank you very much for tuning in. Please support my channel as best you can, like, subscribe to the videos, that'd be awesome. But as always, I will catch you in the next video.